solve the following equation whereby you are given dy over dx plus y over x is equal to y squared. This is an undefined differential equation which is nonlinear. So the first step is we divide both sides by y squared to obtain this. So you are going to have y power -2 dy dx plus y power -1 over x, which is equal to 1. After dividing both sides by y squared, that is what we are going to obtain. So this is equation 1. This is the other equation we have obtained here. We can call it equation 2. Then we are going to let our z be equal to y power -1. The purpose for letting is to transform this equation into linear. Then we differentiate this part here. You can call this 3. You differentiate 3 both sides. So you are going to have dz over dx is equal to -1 power -2 dy over dx. Then from here we can divide both sides by negative y power -2 to get negative. We are going to get negative y squared dz over dx is equal to dy divided by dx. So this is 4. We call this equation 4. Then from there now, you compare your equation 4 with the equation 2, and you take into consideration of also equation 3 to obtain the following. So on the left hand side, we are going to have we shall have negative dz over dx plus, instead of y power -1, this one, y power -1, we are going to substitute with the z over x This is equal to 1. So that is the result we obtain here. We are comparing dz over dx with this equation here. Then the next thing now, you can call this equation. From there now we get our integration factor, which will be given by exponential integral of 1 over x dx as dz over dx minus z over x, which is equal to -1. That is dividing by negative throughout. So now this one, which exponential of power natural logarithm of x, which can be written as exponential ln of x power -1, which is equal to x power -1. Then now we multiply equation 5 with integration factor to get the following. So we shall have x power -1 dz over dx minus x power -1 z over x is equal to -1 x power -1, which can be written as 1 over x dz over dx minus z over x squared, which is equal to 1 over x, using the laws of indices. Now it can be rewritten as follows. It can be written as the same as 1 over x multiplied by z d of dx, which is equal to 1 over x. Now, why are we rewriting this one this way? Because when you differentiate this, first of all, you want 1 over x constant, you are going to get dz over x. Then when you differentiate 1 over x, it will give you minus 1 over x squared z. So that is why you have written it that way. Then we take integral both signs. When you integrate and differentiate, the result is the same. So on the left hand side, you are going to get z over x. Z over x is equal to natural logarithm of x plus constant c. Then you can multiply both sides by x to get z is equal to x natural logarithm of x plus xc. Then we know but our z was equal to y power -1. So y power -1 is equal to x natural logarithm of x plus xc. We can take reciprocal on both sides. It's the reciprocal of y power -1 will be y. Reciprocal of x ln of x plus x, this will give you 1 over x natural logarithm of x plus x multiplied by constant c. So that is our result. And thanks so much for taking time to learn with me on how to solve linear reducible homogeneous equation of first order using the integration factor. For further examples, tune on to my YouTube channel so that we may continue learning together mathematics. Also remember to subscribe to this channel so that you don't miss a single video which I upload for us every day. Bye, see you in the next video. Remember to subscribe also to this channel and to share with the other mathematicians.